All right, this is the quadrilateral exam review. It looks different than my previous, but I'm going to try and do it on the smartboard now. Given that y is equal to 14, x is equal to 7, prove that this is a parallelogram and describe the properties you use. Now, if I'm looking in my handy-dandy notebook, and the reason why I'm saying handy-dandy versus the interactive notebook, because you could use your handy-dandy on the quiz or on the test. So I'm hoping you have that and you're referring back to it right now. So everyone, please take out your handy-dandy so we can make sure that you have this, going over it, and everything is going to be filled out for what you need. This is the quadrilateral review. So quadrilaterals. Should see quadrilaterals in there. All right. So to prove that it's a parallelogram, there's a couple things that I know about a parallelogram. I know that these two angles right here have to do what? Equal to each other. These two are opposite angles. So opposite angles here, where these ones right here are consecutive. Those two are consecutive. So let's start with the opposite. So I'm going to plug in if they're equal to each other, so then that property works. So if I plug in y, so it would be 9 times 14 plus 1. Someone, what is it? 127. All right, and then 10 times 14 minus 13, which gives me 127. Hey, those are both the same. Okay, so that fulfills that property. The property that opposite angles are congruent. Okay, so the next one, let's go with the blue. So consecutive angles do what? Add up to 180, very good. So I know that this one right here, so x is supposed to be 7. So that's going to be 7 times 7 plus 4, which gives me 53. And right here, this one right here, so 127 plus 53 has to add up to what? 180. Does this add up to 180? Yes, it does. And so right here for my property is at consecutive angles. Are supplementary. Okay, so there is my properties that prove that to be true. So I had this much information, I had this much information, so now, do they fit the criteria of the parallelogram? Yes, they do. All of it's true, according to what we had from the quadrilateral. Given the figure below, for each of the following statements, decide whether each statement is true, false, and give your reasoning. Okay, this figure is a rectangle. So now, let's find our handy-dandy notebook and go look at a rectangle. Properties of a rectangle. Opposite sides are equal. Okay, let's start with the opposite sides are equal. Are opposite sides equal? Here's opposite side. Are those equal?
Yes.
Okay, so now let's look at the other side. Are those equal?
Yes.
Okay, so opposite sides are equal. So that fits. Okay, what else has to happen? I don't have the angles on here, but I have another thing that could help me out.
Two pairs of parallel sides.
I don't know the slopes of the sides yet. What about diagonals? Diagonals are congruent. So now let's take a look. What do these little marks in there mean? What do these marks right here mean? They are congruent. They're all congruent. So they're all the same, aren't they? So if this, I'm just going to say, just for the sake of, let's say this is going to be, right here, this is going to be 2. That would be 2. That would be 2. That would be 2, right? So are the diagonal from here and across would be how much? 4. And here across this way would be 4. So we could say that diagonals are congruent, aren't they? Yes, so diagonals are congruent. So I would say this is going to be a true statement. And we have diagonals congruent. And the other one was opposite sides are congruent. That helps me out a lot there. So we're saying, yes, it's a rectangle. Okay? Okay, so now the next one says, is it quadrilateral? Now, let's go ahead and look at our chart. We have that little flow chart things that say what's what. It's also in the handy dandy. It's in the back of the handy dandy, right? I think it's the back page. Okay, so now we're looking at that. We were able to say that this is a rectangle, right? Say yes. Yes. If it is a rectangle, then what do we know about quadrilateral? Okay, but you're looking at the flow chart, right? You're looking at the flow chart. So on the flow chart, if it's a rectangle, is it going to be a quadrilateral?
Yes.
Yes. All rectangles are quadrilaterals. A rectangle is always a quadrilateral. Okay, because I was able to prove this, it is a rectangle. Because of that, I could say yes, because all rectangles are quadrilaterals. I don't know if you guys remember when we were doing that flowchart thing, it's always, sometimes, never. Okay, if it's going up on your list, it's always. If it's going down on the list, you would say sometimes. And if it's in a different branch, it's never. Yes. Okay. Yes. So, if I were to look at it the other way, and so if I'm looking at it down, would I be able to say that a quadrilateral is always a rectangle? If you're looking at the flow chart, is a quadrilateral a rectangle? Sometimes. Sometimes. That would be sometimes because that one's going down the flow chart. If it goes up, it's always. If it's going down the page, it is sometimes. Okay, same thing. So let's take a look at the third one. Is it a square? Okay, what are the properties of a square?
4 equal sides, 2 pairs of parallel sides.
Okay, 4 equal sides. So now it also went with a lot of the things that we had for rectangles. Had the same properties of rectangles, right? Okay, so now, are diagonals congruent?
Yes.
Yeah, diagonals are congruent. Are opposite sides equal? Yeah. Okay, are all sides the same?
Yeah.
Yes, this one right here, because it had a lot of those same rules and all those same things as a rectangle, we just added that all sides are the same. So I would say, yes, that one's going to be true. My reason is 4 congruent sides. Yes, no, maybe. Is this a rhombus? Is this a rhombus?
No.
Why no?
Because yes, it is.
Is it? I don't know.
It has 4 equal sides. Opposite sides are equal. 2 pairs of sides and quarter.
But it's in a different column.
What?
Was I right?
You're right. It is in a different column. But what's different about those 2 columns, right?
That is kind of.
What's different between the rhombus and the rectangle?
Oh, it's that. Height?
No. You're in the wrong column.
Right here.
Look at rhombus.
Height is.
Probably has more sides.
Okay. And
It's the name of the same branch.
yeah, it's in the same branch. Find it in the notes. What is different between a rhombus and a rectangle? Is a rectangle a rhombus?
Yeah. Two pairs of addition, right?
No. Jesus said no.
No, never.
I mean,
It is never. Why?
Because they're not connected. Different branch?
It branches in 2 different places, right? So it's a different size of branch. But now, look at the things in the branches. Look at what it says. What is different in between the rhombus and the rectangle? Right angles.
4 equal sides. Right.
Okay, but we don't know if it has right angles right now. There's something else. What do we have?
That the sides are
Okay, what do we have that's different though?
4 equal sides.
Okay, so one of the things, I think it's on one of them.
4 equal
is
sides.
it opposite sides?
I know it's in one of the things. So,
I was so
okay. Can I see your notes? Real quick. All right, so we're looking at, this is going to be page, so I'm going specifically to this one. Trapezoid kites. There. Okay, so now this is page 77. Everyone look at 77 real quick.
Let me just pull out my.
All right, so 77. What's different about the rhombus and the rectangle?
Diagonals are perfect.
Diagonals bisect each other. Now, does it say diagonals are congruent? It doesn't say diagonals are congruent, does it? So this is a key thing that should end up in your handy dandy, but it's not there now. 77. Right here, we're looking at these 2 right here. So this has diagonals are congruent. This one does not. Okay, in a rhombus, diagonals are not congruent. But if I'm looking right here, diagonals are congruent, aren't they? A rhombus, diagonals are not congruent. Okay, so this is false. So rhombus has rhombus, plural. Rhombus. Is that how you pluralize rhombus? Okay, rhombus. Okay. Do not have congruent diagonals. E-I-A-G-O-N-A-L. Okay. Rhombuses do not have diagonals that are congruent. This one Because earlier we were able to say it was a rectangle. A rectangle has diagonals congruent. Yes? This one, a rhombus, the diagonals cannot be congruent. Okay. Statement 5. Is this a parallelogram? Didn't we already have parallelogram? Quadrilateral. Okay. Now, this goes back to the always, sometimes, and never. Are they in the same column? Are they the same branch? Yes. Okay. So, we proved it at first to be a rectangle. We proved it at first to be a rectangle. So, how often is a rectangle a parallelogram? Always. Always. So, I'm going to say what for my justification here? What's my justification? All. Okay, what did we say? We proved it a rectangle earlier, right? All rectangles. Yes. So all rectangles are parallelograms. Now, was there any key stuff there that you think should be added to your handy dandy on this? Okay, you have the flow chart in your handy dandy, but a lot of those properties that we had on page 77 need to go for each one of your things in your handy dandy. Okay, I did not actually go over it specifically telling you what to put in there. I want you to go through your notebook and find the stuff you need to have in there. All right. 3. Complete the steps of the proof using the following diagram below. Okay. Statement 1. What do you think I should have for statement 1? Parallelogram, right? Parallelogram ABCD, because my reason's already given, right? So my first statement should be what was given to me. There we go. So if it's going to be a parallelogram, there's a lot that I know that goes along with being a parallelogram. So, AB is parallel to CD. But what would I say? What would my reason for that be? Very good. Definition of parallelogram. Because I stated it's a parallelogram, there's all kinds of information I can go.
Well, wouldn't you be able to put that for everything then?
Nope. Close. But close, just because we're going to prove it being a triangle thing. So we're justifying all those things that we actually had from previously. Okay. So we have that those are parallel. I have CAD, so angle CAD is congruent to BDA, so here, and CDA is going to be congruent to BAD. Dang it. Oh. There you go. So I mark the triangles. Now, if I'm looking here, why are these going to be congruent? Very good. Alternate interior angles. 4. I'm looking for the statement on 4, and it says my reason is reflexive property. A what? AD. Yeah, AD. So let's take a look at the two different triangles first before I get too far into this. So I'm dealing with this triangle there
Wouldn't it be?
and this triangle here.
Oh yeah.
So is that easier to see now?
Yeah.
Okay, so now my statement is AD congruent to AD. AD. All right. Reason 5. If you read it, it says triangle ACD is congruent to triangle DBA. Looking at my triangle, ooh, there's one thing I did not mark right there. Looking at my triangle, how are these two triangles congruent? Angle, side, angle, right? I have angle, side, angle, angle, side, angle. Six. These other angles, so ACD is going to be congruent to right here. Now, after we prove triangles are congruent, what can I always say? There you go. CPCTC, right? So what's the mnemonic for this? Chocolate, peanut butter, cinnamon, toast, crunch.
Wait a minute.
Hold up.
What did that even stand for?
Have you been here when we are actually going over any of this?
When did you go over this?
All semester. We started it first semester.
I wasn't here first semester.
This is
Marco.
corresponding parts congruent. Triangles are congruent.
Makes sense.
Okay, a city block is quadrilateral bounded by 4 streets shown. You can kind of see it here. It's not a very good picture. It's a horrible picture, actually. In the table below, find the slope of each line. So this is stuff that we did a long time ago. Okay, finding the slope. So it's basically you're going to turn each one of these into a y equals. So if I'm looking at Pine Street right here, so Pine Street, so I'm going to have, let's see, it's going to be negative x plus 2y equals 4. Turning it into y equals, I'm going to add x to both sides. So it would be 2y equals x plus 4. Divide both sides by 2. Y equals 1/2 x plus 2. Okay, so let's do the same thing to this one right here. So starting off with 2x plus y equals 7. I'm going to subtract 2x from both sides. Subtract 2x from both sides. So it's going to be y equals negative 2x plus 7. There we go. It's in y equals now. This one is going to be 2y equals x minus 6. To get y by itself, I'm going to divide both sides by 2. So y equals 1/2 x minus 3. And then my last one, I really didn't like that last color. It's not a good color. So it's going to be y plus 8 equals negative 2x. What would I do to get y by itself there? Add 8. So I'm going to add 8 to both sides. So it's going to be, or I'm sorry, subtract 8. Y equals negative 2x minus 8. So I subtracted 8 from both sides. Now, the piece that I need out of this to figure out the slopes is the number in front of the x. 1/2, negative 2, 1/2, negative 2. So when I turn it into y equals, that's what you're going to end up having. So when streets are parallel, perpendicular, which streets are parallel, perpendicular, or neither parallel or perpendicular? So let's start with parallel. Which ones are parallel?
The red one and the green one.
Red one and green. So which one is red?
Pine Street, and the green one is
Pine is parallel to
Chestnut Street.
Chestnut. Very good. Okay. What else is parallel? Come on, you guys. What else is parallel? The other two that are left? So you're saying that Elm is parallel to Cedar? Okay. Those are parallel. Now, parallel has the same slope. But what about perpendicular? Do you remember the thing for perpendicular? What is perpendicular?
So they both like intersect with the right hand.
Yeah, yes, that is. That's what's happening. But there's something special about their slopes.
They're reciprocal.
They're reciprocal, but what else?
They make 90 degrees.
We already said the 90 degrees, but something about their slopes.
Oh, doesn't it cut it into two equal parts?
No, that's bisect.
Oh.
It's almost like we wrote this down in the notes. I don't even know what page this one's on.
Wait, what did you say?
Perpendicular.
What about it?
What about it? What about the slopes for perpendicular? I know we did it in the notes. Because we were actually, I know it had something to do with some, like diagonals or something like that, or
Are they opposite?
we had a graph.
The graph.
We did have a graph, and then I was talking about a bunch of slopes and. Ah, look, there it is. I think that's 73. 73! Page 73. Please check that out.
Oh, they're opposite? Oh, opposite sides?
Opposite signs. Is there anything else?
Reciprocal slopes.
Opposite and reciprocal. So when we're doing perpendicular, you have to have opposite and reciprocal. Opposite and reciprocal. So let's take a look at this. Let's compare these one right here. Let's do the red and orange. Are they opposite signs?
Yeah.
Yes. What's the reciprocal of 1 over 2?
2/1.
2 over 1. Is this going to be 2 over 1?
Yeah.
Is this red one right here, or the orange one 2 over 1? Yes? Okay, so we could say that pine is perpendicular to elm. And we could also say, what's the other one? So chestnut is perpendicular to cedar. So on the test, you have to have that information. Yes, I told you guys to find it in your notebook, but it has to be in your handy dandy so you can have that. Okay, so you just have to go back through and write out all your work. If you want all your points, you have to write out all your work for this. Yes.
So would we have to write like the other two?
Yes, all of them. Because it says streets parallel, perpendicular, or neither. You might have neither perpendicular, parallel. Like these ones work out very well. So here, 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 and here, they all work out very well. But you might have like a weird one where it's going to be like 5x instead. Would 5x compare to the rest of these? It would be neither compared to any of it, right?
That is not what I asked.
Okay, so I didn't understand the question then.
Okay, so like pine and what Steve Setter or whatever, they're also perpendicular. Will we have to write those two or no?
Oh, no, no. Okay, I know what you're talking about now. Okay, so yeah, pine is going to be perpendicular to cedar, and then elm is perpendicular to chestnut.
Does it matter
Good catch.
which ones you
Hold
put?
on, let me write this down.
As long as you have those?
Yeah, if you have them, because they're parallel to each other, pine is parallel to, let me see, pine is parallel to chestnut. So pine and chestnut could be interchangeable for those right there.
Oh.
Make sense? Okay. Part C, Acorn Street is parallel to Pine Street. Now, parallel have what?
Same slope.
Same slope. What was the slope of Pine Street?
Wait, Pancho, we're only about 4 minutes.
1 over 2. I'm trying to get through it. So my slope, okay, and the equation of this. Now, we did this back in first semester for a very short time. My formula is y minus y1 equals m quantity x minus x1. Where this is my y value here, this is my x value there, and my slope goes there. And so it just, so you only plug in the ones that have this one right here, the ones. So it's going to be y minus, my y value is -2, equals my 1/2, parentheses x, minus my 6. So y minus -2. So that's going to turn into y plus 2, right? Equals, go ahead, distribute that. 1/2 x minus 3. And I'm almost there. Has to be into y equals. Subtract 2. Yeah, that's it. So I turn it into y equals. Oh, that's way off. All right, so we're gonna pick this up tomorrow. We're gonna do 6 and 7 tomorrow. Don't forget, work on your notebook. If you don't have your handy dandy with you today, make sure you have it tomorrow. Okay, make sure everything you need is in your handy dandy.